We're going to learn about list boxes, so we can put lists of items into what looks like an oversized label, but it is a list box. So let's go over to the toolbox and get ourselves a list box. Not a checked list box, just a regular list box. We can resize it however we want, and we can also change font size, background color, foreground color. I'm going to change the name of this to LST. Mine's going to be LST.Dessert. The three-letter prefix you need is LST. You can make your list box about whatever you want it to be. We're going to put a list of items in there. And again, you can adjust the font and the foreground color and the background color as you would like. The three-letter prefix is LST, and mine is going to have dessert items in there. To populate the list box, I'm going to go to the Items property of the list box. Click there, and then there'll be three dots that show up. We'll click on those, and then you'll see where we can enter in our list of items, hitting enter after every time to get to the next item. Be careful, don't put spaces after these unless you really want them there, because that's going to be important as we look for matches. So I have no extra spaces on these lines. It's enter right at the end of all of those yummy desserts. And when I run the program, you see them there in the list box. I can click on them as well to select them. We'll check that out a little more later on. And once you're in the list box, you can use the up and down arrows to move around. Well, there's lots of things we can do with the list box. One thing we can do is count the items. So if we ever need to know how many items are in a list box, we can use this .count property we're going to see. It's actually .items.count. I'm putting it in a message box to display. So here's my list box, LST.Dessert.items. Remember the .items, .count. That returns an integer. If you don't put the .items there, it's not going to work out. It needs the .items.count. And then however many items are in the list box, that's what's going to display. And we'll see that we have 7 desserts. You can count them for yourself. Remember, the .count property returns an integer. So if I remove these string literals and I want to display this in a message box, I'm going to have to bust out .toString, because .items.count will return an integer, and it is a count of how many items are in a list box. I'll reset that back. An advantage of lists is that they can expand and contract in size. So if we want to add an item to the end of the list, we can do it with .items.Add. And then in parentheses, we'll put the item we want to add. I'll go with a brownie. And this will get added to the list at the end of the list. And I just keep clicking it and clicking it. You'll notice that a scroll bar automatically will show up on a list box if items is larger than what the capacity of the box is to display. So that'll automatically show up for you. Well, I've got a text box down in the bottom, so users can actually type in what they want to add. So I'll put txtitem.text.trim to remove the spaces. So I'll type brownie down here this time, add the item to the end, and there it is. Kind of a pain to have to go back and highlight to delete that stuff out of that text box. So I'm going to remove the text of that text box or clear it out every time. We get ourselves another brownie, add it to the end. And I still got to click back in there. So how about putting the focus back there as well? txtitem.focus. So we can get a brownie in, add it to the end of the list, and then we can add a cake to the end of the list. And the focus is going right back to that text box. But it's .items.add. We can add items to the end of the list. Be careful though, here I was adding absolutely nothing, and it still got added in. Notice when I click add item to end with nothing in the text box. Better do something about that. I want to make sure there's actually something in the text box. So I only want to do it if there's nothing there. So if txt item.text.trim does not equal nothing, that trim will take care if they just put a bunch of blank spaces in there. Otherwise, if it is nothing, once we trim out all the spaces, if there's nothing left, that means they didn't really put anything there, and we'll give them a message to tell them that they really need to put something in the text box if they want to add something to this list. So now there's the message, and we aren't going to get a bunch of blank lines hogging up our space in our list box, confusing us. You'll notice Brownie's going to go into the very next spot right after Snickerdoodle once I click the correct button. So .items.add will add an item to the end of a list box. But what if we want to remove an item? I've told you lists can expand and contract. It's very similar code. I'm going to go to the add and copy and paste it. Now we'll switch. It's going to be Items.Remove. So whatever it is we type in the text box, it will be removed from the list if it's there. So we'll go with Jelly Donut, which is in the list. Remove item. It disappears. It's gone. It's totally removed from the list, and everything shifts positions. If I try to get a cupcake, I try to remove it. It's not there. It doesn't crash the program. It just doesn't remove anything because it couldn't find it. I'll try to remove ice cream. It's gone. And then Snickerdoodle was able to shift into that vacated spot. All right, I'm going to add some repeats here. I'm going to put in Bear Claw again, ice cream again, and Bear Claw one more time. Because we want to see what happens when we try to remove an item that's in multiple times. So, if we get rid of ice cream, if we want to remove ice cream, it's in there twice. And it's only the first instance that goes away. So, .remove will take care of the first instance it finds, and that's it. So there's the first instance of Bear Claw gone, the rest remain. If I want it to go away again, I'll have to type it in again. So there's not a remove all. And once again, a reminder that if it doesn't find it, nothing crashes, just nothing gets removed. It only removes it if it's there, and it only removes the very first instance. A super easy thing to do is to clear out a list box. The name of the list box, .items.Clear. And use parentheses. That's it. That will wipe out everything in the list box. The list box still exists, but there's no items in there. They are all gone. So if you want to add items to the list to get it going again, that's what you'll have to do. Now, chocolate chip cookie is in what we would call an index of 0. Peanut butter cup is at 1, Bear Claw 2, strawberry cheesecake 3, jelly donut 4, ice cream 5, snickerdoodle 6. There are 7 items, but they are in positions or index values 0 through 6. 0, 1, 2, 3, 4, 5, 6. So the last item is always at an index of 1 less than the count. Very often in computer science, we start counting at 0, and chocolate chip cookie has an index value of 0. So this lets us know the positions of things. I'm copying and pasting the label and text box that I already had because I'm going to need a way to have users select an index when we want to insert items at a certain spot and remove items at a certain spot. Looks like they're all ready to go. I made the text box called txt index. So to insert an item somewhere in the list, not just at the end, but anywhere we want, that's going to be our list box, .items.Insert. And there's 2 things to know. What position do you want it, or what index value, and then what is it you want to add? So I want to go to index 3, and that's where I want to insert Brownie. So again, to insert, we need to know 2 things, where and what. Right now, at index 3 is strawberry cheesecake, 0, 1, 2, 3. And that's where Brownie goes. And everything else is shifted down the list. Again, with .insert, we need to know 2 things. What index do you want it at? And what is it you want to put in there? I'm going to declare index as a variable now, int index. And I will make it equal 3. And then inside those parentheses with those 2 arguments, I'll just use index as a variable. You'll see why in a little bit. Still works the same way. Brownie goes into the index of 3. and everything else shifts. All right, now I'll get rid of that equals 3 because we're going to have the users tell us where they want the item to go. So we'll use int.tryParse. If int.tryParse txtindex.text.trim, we want to get the value out of that second text box that we just made, and we want it to be an integer. If it works, we're going to send it out to index. We know that's the index, that's the position where they want to insert. Right now I have brownie, but we've got another text box where they can put in whatever dessert item they want. So that's txtitem.text.trim. So as long as they type in an integer, that should work out. Otherwise, we know they didn't type in an integer. We can test this out. So I'm going to type in brownie, and the index we're going to use is going to be 3. Insert item, there it is at position 3 or index 3. If we try to put a cupcake at index 1, there it is. Peanut butter cup was at 1, but now cupcake is at 1. It's been shifted down to 2. That error message works okay. However, we still have some other issues to deal with. So imagine we want to put a brownie at the spot 9. Ruh-roh. That's out of range. There's not a position of 9 available because the length of it or the count of it is only 7. The last spot was 6. So that would crash our program. So once we know we have an integer, if we make it through line 80 okay, now we got to check and make sure it's actually within the range of what we need. So index has got to be at least 0, so greater than or equal to 0, and it's got to be less than the count. So it's LST, whatever your list box is called, .items.count. Because if the count is 7, then 7's not good, but 6 is okay. So I'll slide this line of code in here. I didn't make an else for this. We could have also generated an error message to let them know that their index value was out of range. So now we'll try to put brownies in at index 12. And it doesn't work. Again, I didn't put an error message in there, but at least it didn't crash. Try to put it at index 2 and it does work. So that's how we can insert into any spot we want in a list box. .items.add always puts it at the end. .insert, we tell it where we want it to go and what we want it to do. Going to mess around with some clear and focus things. We'll see how this works out. Sometimes it's a matter of what was it, where was the mistake, or where were they trying to actually type stuff in? Where does it make sense to go next? So, brownies, or a brownie, at index 6, insert item, there it is. And I got the item to go away, but I didn't get the index to go away. So I need to add that in there as well. Index.Clear. Then it's hopefully totally resetting. Check it out. Now, if we clear the list out and then try to insert in, nothing happens. No crashing. So those are some of the things we can do with a list box. We'll see more of them in the next part of this lesson, Part B.